Welcome to the sixth session of Module 16th on blockchain and smart grid analytics. So far, we have actually gone through various learning sequences of blockchain in terms of understanding the technology, what it is, how people are using it, particularly in the arena of smart grid analytics, what blockchain use cases are. And in the previous session, we also saw how high hyperledger composer can be used in terms of getting a solution up and running. In this session we'll have another video which will show in due course of time, which will take you through the steps of building a solution on your own, right? And we'll also take you through a novel way of learning any technology, for that matter, not just blockchain, which you call as code patterns, right? So in order to learn a technology, the best way is to get your hands dirty with it, right? And to start experimenting with blockchain, you need to build a model, a particular network, and then build a blockchain application using a Hyperledger Composer toolset for this example. The code pattern that I'm going to discuss now, the application presents a decentralized energy network where neighborhood residents who are producing energy through solar panels or other means of renewable energy can sell excess energy to fellow residents or utility companies. I'm basically referring to a link on GitHub, github.com/ibm/decentralized-energy-composer. Now let's understand how this application work, right? This particular application allows the user to create a network participants with account balances, who can exchange coins for energy shared. The network also includes bank to exchange the cash for coins. So the transactions can be between residents, between resident and bank, or between resident and utility company. The application updates balances for each transaction, and each transaction is added to the blockchain ledger for trust and verification. Now, once you create the application, you can expand it in so many ways, right? For example, you can add some permissions for participant access. You can set up some real-time transactions between participants and even integrate it with the IoT to read from power meters and distribute energy. There are a couple of factors in this particular application. The administrator interacts with the decentralized ledger UI, which comprises an Angular framework. The application process user request to a network through a REST API. The requests are implemented to the blockchain state database in a Hyperledger Fabric version 1 we are talking about here. The REST API is used to retrieve the state of the database, and the Angular framework gets data through GET calls to the REST APIs. Here you can integrate the video. The link is basically provided on the slide. The YouTube link is there. Once the entire video is played, you can add the subsequent section.
Hello everyone, welcome to Decentralized Energy with Hyperledger Composer Journey. In this video, we'll first talk about the concept behind the application. We'll look at the architecture flow. Then we'll look at the steps to running the application and run the application and see how it works. And then we'll look at the composer model in Playground. So let's get started. So a key application of blockchain being currently explored is a decentralized energy network. And this idea stems from a neighborhood where certain residents are producing energy through solar panels or other means and would like to sell their energy to their neighbors. And so the transaction would be based on coins, and which would be exchanged for the energy consumed by the consumer. And so at a predetermined contract and rate, the coins would be deducted from the consumer account and added to the producer for the period which the energy was exchanged. And each transaction would need to be atomic and added to a blockchain ledger for trust and verification. And the network can include banks to transact coins for cash, like fiat currency, like US dollars. And the network can also have utility companies who can provide energy for coins and buy energy for coins. So let's look at the architecture flow. So here we have an admin interacting with the web UI, which we will see shortly, and makes requests to the network through the Composer REST server. And then these requests are implemented on the Hyperledger Fabric v1, and then the Composer REST server is used to get the data from the network to display on the web UI. So the components here include Composer, which is used to create the blockchain network and the blockchain transactions. Angular framework is being used for the front end, and loopback is used to create the Composer REST server. So now let's go ahead and run the application. And these are the steps detailed to run the application. First step would be to clone the repo, which I have done. Then we would like to set up fabric, and these commands, the docker kill and remove images, these commands will remove all previously created Hyperledger Fabric chain code images and processes. So we'll start from here. We'll set the Hyperledger Fabric version to v1. I have already downloaded the fabric images, so we'll go ahead and start fabric. Next, we would like to create a composer profile which interacts with the fabric network. And here we see the peer and the order being created on the fabric. Now we're creating the composer profile. So once that is done, we want to generate our DNA file, or also called banana file. Npm install. And you should see something like this, where it says created the business network archive with command succeeded. Next, we would like to deploy this banana file to the Hyperledger Fabric. And here, on here we see it deploying the business network to the Hyperledger Fabric. And then we can verify the network has been deployed by sending a ping command. So once the network has been deployed, we'll go ahead, ping the network to see that it's been deployed, and we get a command succeeded here. Now let's go ahead launch our application. I'm going to use npm start to start our Angular app. Now let's go ahead and look at our application, which will be at localhost 42,000. And there you go. Using Bootstrap for the initial interface. So now our first step would be to create and update participants. And then our second step will be to execute transactions and see how their accounts are being updated. So let's go ahead and create our residents. Say 100, and we can give like one balance. And first, it's going to create the coin assets, the energy asset, a cash asset, and it will assign all those assets to a resident. Let's go ahead and add our second resident. Since he's a consumer, we'll give him 5 kilowatt hour energy. and go through the same steps. Once our two residents are created, we can see under assets like the coin asset being created, the energy asset, and the cash asset, which is associated with each owner. And now let's go ahead and do a resident to resident transaction. So we're assuming a billing period of between 2 to 4 p.m. and we're saying our neighbor one, R1 is our producer, saying R2 is the consumer, and we want to exchange 10 kilowatt hour of energy. And the rate is 1 coin per kilowatt hour. So we should see a transaction where the producer's energy is deducted but coins are credited, and consumers' energy is increased by 10 kilowatt hours, and the coins are deducted. Let's see that. Once we execute the transaction, it will show a transaction ID. And let's look at our residence accounts, and we see that the coin balance for the producer was increased by 10. The energy value went from 25 to 15. And for the consumer, the energy increased from 5 to 15, and the coin balance decreased from 1,000 to 990. And then similarly, we can create a bank. And let's look at our coin assets, and we'll see like a bank coin asset was added. Let's go ahead and do our transaction between resident to bank. And here we can get cash for coins or coins for cash. So let's say that the producer wants to sell coins for cash. And here the rate is 10 coins per USD. So we'll say cash value of 100 for 10, which would be 100 coins. So let's go ahead and execute the transaction. Similarly, we see a transaction ID. And then if you look at our residence, we see the coin balance got deducted by 100 and an increase of 10 in the cash balance. And then same thing under banks, we'll see that the coin balance was incremented 100 and cash balance got deducted by 10. And we can do a similar transaction between by creating a utility company and doing a transaction between resident to utility. So I do want to point out that we have a REST server at localhost 3000, and here we can test, we can see all the REST API commands for each entity, and these are our transactions, which are all processed through the Composer REST server. Let's go ahead and take a look at our model. So our model consists of resident, bank, and utility companies. And under each resident we see, so a resident would have a coin asset, a cash, and energy. And a bank will have coins and cash, and a utility company would have coins and energy, defining owner entity. And then we're creating these coin assets, energy assets, and cash assets, with the value being the main of indicating the balance. Every asset is identified by ID and owner ID and owner entity as well. And then we have two transactions happening. One is exchanging energy for coins, and where a rate is being sent through with the energy value, and then the coin accounts are incremented, decremented, and same thing with the energy account being incremented, decremented. and we have a similar transaction for exchanging cash to points. And I want to show some features of Playground where we can actually test uh, our transactions. And here I've already created our residents with their cash value assets and coin assets. So if you want to do energy to coin, we just say energy rate 1. And we're telling it which coin assets to increase and which to decrease, and same thing with which energy asset to increase and which energy asset to decrease. This will be part 2. And then if you look, we see that the coin value got incremented here, decremented here, and then same thing for energy, which again went from 25 to 15 for the producer, and went from 5 to 15 kilowatt hour for the consumer. So that is how the application works, which shows the transaction being atomic transaction occurring on our blockchain through Composer. And it's easy to set up and get started with. And this journey, and after you're done, you can stop the fabric and you can tear down the fabric as well to start on it, for if you would like to start again or start on a different project. And in some ways, this journey can be extended is by adding specific permissions and participant access, or setting up real-time transactions among participants, or integrating with IoT to read from power meter and distribute energy. Thank you.
As you would have understood, with the example video, that one of the code patterns in making use of is making use of blockchain and creating solution for decentralized ledger for energy. Now, code patterns are the cool ways of learning particular technology and practicing a technology, right? I would rather, emphasize you to remember the link developer.ibm.com/patterns. Now, this particular link has almost 200 plus code patterns for any technology for that matter you would like to learn, right? A couple of them can be analytics, API management, artificial intelligence, blockchain, deep learning, IoT, DevOps, quantum computing, just to name a few, right? So there is this snapshot which details out all the technologies which are made available as code patterns for you to learn. Wish you all a happy learning and happy exploring blockchain technology. Thank you.